Alright gentlemen, now turn with me to chapter 7 and page 11. Okay, today we're going to integrate exponential functions. And as you can see, because of the effects of chain rule, okay, we need to divide by a in order for you to remove, okay, the effects of chain rule and arrive at this expression here. So without further ado, let's take a look at part A. We have the integration of e to the power 3x plus e to the power minus 2x dx. Alright, so you can split the integration to arrive at e 3x dx plus integrate e to the power minus 2x dx. Okay, so the next step is to simply remove the effects of chain rule, and then what we have is 1/3 e to the power 3x plus, alright, negative 1 over negative 2 e to the power minus 2x and plus c. Okay, and what we get is simply equals to 1/3 e to the power 3x minus half e to the power minus 2x plus c, and that will be our answer for the first part. Okay, so at this point you may notice the effects of chain rule for the final answer. When you differentiate the answer over here, alright, you arrive at this expression here. So for part B, okay, we have the integration of 4 e to the power 3x minus 3 over e to the power x dx. So just like what we see in differentiation, in this kind of setting, we usually split our terms into two parts. So what we have is integration 4e 3x over ex minus dx minus 3 over ex dx. And what we have is, okay, 4 integrate e to the power 2x dx minus 3 integrate e to the power minus x dx. So what we get is simply equals to 4 half e to the power 2x minus 3 minus 1 e to the power minus x plus c. So what we get is simply equals to 2e 2x plus 3e minus x plus c, and that will be our final answer. Okay, so for part C, what we have is 4 times e to the power 2 minus 5x dx, and what we get is equals to actually 4 integrate e to the power 2 minus 5x dx. Okay, and this is actually simply equals to 4 integrate e to the power minus 5x plus 2 dx. Okay, so right now you realize that the power is a linear term, and then to remove the effects of chain rule, what we get is equals to 4 over negative 5 e to the power minus 5x plus 2 plus c. Okay, and why did we divide by minus 5? And that is because when you differentiate this, you need to multiply by minus 5. So this negative 5 actually removes the effects of chain rule. So what we get is equals to negative 4 over 5 e to the power minus 5x plus 2 plus c. And that's all for the answer. Alright, so the next kind of question, we are looking at this kind of function here, where you have the differentiated function in front of the exponential function, and you require some observation to do such integration. Okay, we will skip part A and we'll jump to part B. So for part B, we have integration of cosine x e to the power of sine x dx. So by observation, we know that when we differentiate sine x, we get cosine x. So as a result, this integration will simply be e to the power of sine x plus c. Okay, I say that this requires some observation because if you notice that if you differentiate this function here, you get back e to the power of sine x, and because of chain rule, you multiply by cosine x over here. Alright? So whenever you see this, you need some observation to arrive at your final answer here. So this is my final answer. Okay, then for part C, we have the integration of e to the power of root x over root x dx. So recall that when you differentiate root x over dx, it's actually differentiating x to the power half dx And what we get is actually half x to the power minus half, which will give us equals to half times 1 over root x equals to 1 over 2 root x. So since there is an additional half over here, okay, so what you need to do by observation, this answer is simply, okay, 2e root x plus c, and that's all. Okay, so right now if you work backwards, if you differentiate e to the power of root x, what you get is actually e to the power of root x again times 1 over 2 root x. And then in order to remove that additional 2 over here, you need to multiply by 2. And that's why you have this answer over here. So this kind of question requires some observation.